Every experiment has a hypothesis. If the researcher doesn't think their experiment will show them anything, they might as well go back to bed and spend the rest of the day watching Buffy the Vampire Slayer. Or Twilight. Or maybe Dracula if they're more of an old school vampire sort. A hypothesis is the researcher's expectations of the results before they start the study. Sometimes they predict the outcome correctly, sometimes they don't. Either is fine, and they'll print their hypothesis when publishing the results, even if the results show that their hypothesis was in fact wrong. Asking for a friend here, I don't think I can think of another profession outside of science where professionals so readily publicise that they were wrong. Can you? Anyway, if a hypothesis is a prediction about the results of an experiment, what's all this funny talk about directions? What is a directional or non-directional hypothesis? Well, the difference is simple and nothing to do with map reading. Directional hypotheses state the expected direction of results, whereas non-directional hypotheses just state that there will be an effect, but without specifying in what way. Let's use some examples. Rooms with more lamps switched on will be brighter than rooms with fewer lamps switched on. Is directional. The direction in this case is that the room will be brighter. The brightness of the room is the dependent variable, and the number of lamps switched on is the independent variable, the one being manipulated by the researchers. On the other hand, the brightness of a room will differ depending on the number of lamps switched on, is non-directional. We've stated here that we predict a difference, but we've not said whether the room would be brighter or dimmer, just different. Let's take a look at a real-life hypothesis published in a psychological journal, and then we'll tackle the question of when to use directional hypotheses and when it's best to go with a non-directional hypothesis. Here's the hypothesis from Demarest et al.'s 1984 study entitled Words Speak Louder Than Actions: Understanding Deliberately False Remarks, which is a really interesting paper about how people of different ages understand sincere, deceptive, and sarcastic remarks. Here's their hypothesis. See if you can tell whether it's directional or non-directional. In line with the earlier research, 3 steps in understanding are predicted. First, children assume that the speaker's belief and communicative purpose are both in line with his statement. All remarks are taken as sincere. Next, children appreciate that a speaker's belief may be inconsistent with his statement. Both types of deliberately false remark are taken as deceptive. Finally, children recognize that a speaker can both not believe his statement and not want his listener to believe it. Deception and sarcasm are accurately discriminated. Directional or non-directional? This is absolutely an example of a directional hypothesis. In this study, the direction is that as a child grows older, they'll be able to understand the difference between someone telling the truth, someone lying, and someone being sarcastic with increasing accuracy and ease. The researchers even draw attention to the direction by using directional prepositions, such as first, next, and finally. Whilst we're here on this example, can you identify the independent and dependent variables from the hypothesis? Remembering that the dependent variable is the one being measured and the independent variable is the one being controlled by the researchers. Well, in this case, the child's ability to recognize communicative intent is the dependent variable. Can they tell the difference between sarcasm, the truth, and a lie? Well, what's that dependent on? The age of the child. Therefore, the age of the child is the independent variable that is being controlled by the researchers, either by using a time machine or by recruiting participants of different ages. Let's round off this video by clarifying when to use a directional hypothesis and when it's preferable to go non-directional. Well, The basic answer to that question is, if you haven't got the foggiest clue what your results are going to show, stick with a non-directional hypothesis. This is likely to be in situations where you're conducting research in a brand new field. If no one's researched your topic before, you've got nothing to base your hypothesis on. Other times you might see a non-directional hypothesis is when previous research has provided contradictory results. So again, you really don't know which way things are going to go. However, if there is pre-existing research that you've read before conducting your own research, then you'll be able to present a directional hypothesis because you are intending from your study to build on top of the existing research in your field. Domeris et al. Make this super clear at the beginning of their hypothesis by stating "in line with earlier research." As soon as we read that, we could be pretty confident that we would be reading a directional hypothesis. My directional hypothesis for this video is that anyone who watches this video to the end will score higher grades in their exams. My non-directional hypothesis is that exam grades will differ depending on how much of the video you watched. Either way, I hope it helps. Thank you for watching this video. I really hope you enjoyed it and learned something. And if you did, please give it a thumbs up and share it with a friend. If you haven't done so already, please click the bell when you subscribe to Psychology Unlocked, and that way you won't miss out on any of our upcoming videos. Thanks for watching. I'll see you next time.